Welcome back to Arcade. I am Super Tommy, and this is a series where we're going to make a dungeon crawler in Phaser 3. Now, in the last video, we added a tile map that you can see here using tiled. We created this in tiled. And in this video, we're going to make a character to walk around our level that we created. So first, I'm actually going to start my dev server. This is using the Phaser 3 parcel template from the Arcade GitHub. You can go to github.com/arcade to find it. All right, now that we have that running, let's just refresh this. Cool. So we are using the character here. This is from Itch. It is the Legend of Faune character. You can get this as well. This is from Louis Zuno in Itch. So there's a sideways movement animation, and up walk animation, and run, and a down move animation. So we're going to use this character. So what we've already done is we've created a atlas for our character here. So this is an atlas. You can create atlases using a texture packer, including the fairly famous texture packer or fairly popular texture packer from Code and Web. It is a great tool. I've used it in the past. If you can't afford this program for whatever reason, there is a free version, not of this specific program, but free texture packer or freetextpacker.com. You can use this. There is a download for, I think, Windows, Linux, Mac, as well as on the web. So you can use that as well to create your texture atlases. So we've done that already ahead of time. The asset here from Itch provides you with individual PNGs that you can throw into the app and then make one of these yourself. So we have this and it'll produce a JSON. So we're going to load all of this inside Phaser. Let's get out of there. Let's go back to our game. And let's see, we've been preloading everything inside preload. So let's preload. So this .load.atlas, and we're going to call this, we'll call this Faune or Fawn. I'm actually not sure how you pronounce this character's name. It looks like Zelda, looks like Link, but both Link and Zelda have easier to pronounce names. Okay, so character slash dot. This wants the texture PNG, and this wants the JSON first. Atlas URL. Yeah, okay. Slash. Oh, so okay, first one is texture, I think at least. Let's see. Let's string texture atlas. Okay, so there's that. So that's loaded, or that will be preloaded. There's an error. Characters. Fix that? No. Let me just make sure what I have here. Oh, it is character. Fauna. I called it fauna in my atlas, so we'll just go with this fauna, not faune. Fauna being plants, I think, the scientific term or something. All right, that error's gone. That's loaded. Let's go to game. We'll leave this for now. Okay, let's not get carried away. I was going to do some refactoring. I'll do that maybe before this video is over. I'm just going to get this debug graphics to a different function. But let's just add our character. So we want this .add.sprite, and let's just put put her 120 and 128 texture, that frame. So the frame, let's say we want that down, run down. Oh no, how about walk down? This is the frame name, which is also going to correspond to the name of the PNG that you put into your texture packing tool, usually, if that's how they exported it. So that's the frame. That's fawn A. Let's see. We should see something if I did this right. And there she is. Okay, so that's a sprite. Now we need to add animations. In Phaser, all sprites can access all the animations, so their animations are global once you add them. So let's just do this. So we'll do this dot anims. That's the animation manager. Dot. I'm going to create a new animation key. So this is the config for animations. You can, if you're using TypeScript like I am, Visual Studio will give you all the various keys that this config object expects. Alternatively, you can go to phaser.io and go to the docs and see exactly what it expects. So we go here, API docs, and then there's many ways to get there. What am I doing? Anims. Anims, and then you find the create method, right? And it takes the config you see right here. And then this is the type. You click on that and it'll tell you exactly what you need, if it's optional or not. I think almost everything here is optional. And then something like frame has a even bigger object type within it, and we'll get to that. But first thing, key. This is key the animation associated with. So let's call this fawn A. Let's call this idle. So idle down, right? Because she's facing down, and this is her idle, which is what she looks like right now, right? This is basically idle down. So frames we saw takes an array of frame objects. So here frames is an array of animation frame objects, and this is what that needs. And in our case for idle, it's just going to be one frame, which basically is the walk-down-3.png frame. So we're going to do key. This is the key of the animation associated with. I'm pretty sure this actually should be this. And then this frame is going to be this. Okay, let's see. If I did it right, and if I do this dot anims dot play fawn A dash idle dash down, we should see no differences. Theoretically, I did it right. Now, this is an easy one. It's only one frame. Let's now do this dot anims dot create the walk down, or the run down, or the move down. So we're going to call this fawn A. How am I doing? Idle. So this is going to be, let's call this run down. Now you notice that I'm keeping the same structure here. It will be important later. It's not quite important right now, but it will be later, and you'll find out why. So for now, just do it this way. You don't have to necessarily keep the same structure of name dash some state dash some other property. In this case, down is going to be up or side is the other options we have here. And so this is to be an array, but now we know that our rundown animation has multiple frames, not just one frame like this idle. So instead, we're going to do dot generate frame names, because Phaser has a utility that will generate these frame names for us, because generally speaking, you'll see that, so let's just look at rundown, right? So rundown -5, rundown -8, -2, so they have a pattern. And in this case, it goes from 1 to 8. If you throw them, you see it goes, the max is 8 and the min is 1. So we're going to generate frame names, and then now this takes key, which I believe should be that. That's the actual atlas that we loaded, the key of the atlas. And then now the config, it's going to have, oops, in Visual Studio Code, if you want to bring up the help, it's control space. So there's here start, end, prefix, and suffix. That's what we're going to be using. We're going to basically construct where you saw before run dash down dash one dot png. So we're going to start, and it's 1, and then we're going to end at 8. Prefix was, let me just copy it actually. So run dash down dash, right? And now suffix .png. So what this method, this utility method is going to do is generate an array of all the frames like we did here, right? So basically it'll have multiples of this, but it'll create this string for us programmatically so we don't have to write it out, in this case, 8 times. So let's save. We should get no errors. Number 1. Okay, no good, no errors. So now if we do this, we should see her run in place. Yes. Now it did not loop, but you should have seen that she was running. So now more config here. There's repeat. We set it to -1. It'll loop forever. She's running very fast. The next thing is frame rate. Let's just say 15. This is the frame rate of the animation, not the frame rate of the game. Now your game could run at 60 or whatever the refresh rate is. It's probably going to be 60, generally speaking. Different devices may be slightly different. For your computer, it's almost certainly going to be 60. And this is the frame rate of the actual animation itself. Now your game will be at 60 or whatever it is, and this is the animation frame rate. So we'll just pick a number that looks good, 15, it could be 10. 10 is probably too slow. We'll just go 15. Great. So that's that. Now we're going to do the same thing for run side, run up. So let's do that. So it'll be very similar. Fun A dot. So we'll just do run up. And then frames. We can, in fact, just more or less copy this because it's going to be the same. So let's just do that. Okay, but we're going to change this. Run up. In our case, there should also be 1 through 8 run ups. Yes, the max we saw was 8 and the min was 1. If you're using different art assets, it may not be the same, so just check how many PNGs you dragged into the texture packer. So there's that. Let's give this a test. Now she'd be running up. And there she is. All right, next, this.anims.create. Let's just copy again. We're going to do side. This particular set of art has a, they called it run side. So what, and I think it's facing right. Let's see, run dash side, yeah. And there is also 8. Okay, so that should be good. Run dash side. Okay, so that's her walking right. So we are going to use the same side animation for both left and right. We're just going to scale x -1 to flip her from facing right to facing left. And let's not forget, we need our idles. So we go back up here and create our idles. I just like to keep my idles together. There's no, you don't have to. This is just me. So it's similar, idle up. So what I've done ahead of time is taken her walk frame from the third frame of her walk animation as her idle for all the various directions, down, up, and side. And so what we have here is going to be walk up 3. You can pick different ones if you find that you prefer a different type of idle. Idle frame for idle, or if you wanted to make an idle out of the frames that you already have. So let's just make sure here. So walk up, very good. Walk down, very good. Walk side. Okay, so that is what I called it, or what it was called. So these are the idles. Okay, so we're gonna make her idle down start. Okay, so now we want to do is actually move her around. So first we need to get input. So this is TypeScript. We're going to make a class property here called cursors. We're going to use Phaser's pre-made cursor keys. Let's see, maybe types dot input dot keyboard dot cursor keys. And we're also going to tell TypeScript to trust me, this will exist just to make the code a little more simpler. And so we don't have to use the non-null assertion operator. everywhere, which I've known some people have been confused by that. What was I doing? Cursor keys, yes. So I'm actually going to do get these cursor keys in preload, although you can get them in init or even in create, but just to segregate the code a little bit, cursors, this dot input dot keyboard dot create cursor keys. So this is going to create the arrows and the space bar for us. These are just common cursor keys for most games. See, we'll use arrow keys in space, so that's what we're going to use. Okay, so there's that. Now we need to handle this in update. So as you see, font here is a local variable, local only to create, right? So you can't access font in, say we make this update, and it's number. So this is first, the t is total time, and dt is delta time, or the change in time since the last frame. We probably won't have needed, but I just got used to writing because they are provided by Phaser when you use the update method. Okay, so we have access to the cursor keys. It's a class property, but not to fawn or fawn because she is local. Currently, this variable is local only to create. So we're going to change that, and we're going to make another class property. Also, just trust me, TypeScript is going to exist. Phaser.gameObjects.sprite. And we're going to go this dot. And then over here, this dot. And okay, so now just for safety, we're just going to say if not cursors, I definitely spelled cursors wrong. Cursors. Let's fix that. Cursors. Okay. If cursors is null, so this is what not cursors mean. Basically, in JavaScript, anything that is zero, null, undefined, you can also say is false. It's not exactly false, but if you do a not zero, not undefined, not null, it would be similar to saying not false or not true. So in this case, if it's not that, or it's not this not so A, so if they both don't exist, just don't do anything because they're just their errors anyway. Okay, so now we're going to use the cursor keys to move our character. So this dot cursors dot left dot is down. Okay, so if we are pressing left, we are going to want to move left. Now, we could manually move the X, or we can right now turn font into a physics object. We're going to do that instead of manually moving because we're going to want her to hit these walls anyway. So let's just do that. It's going to be very simple. We're going to, instead of do this add, we do this.physics.add. And then, of course, she is now a phaser.physics.arcade.sprite. That's it. Nothing else has changed. If we save it, it should still work. Yep, no errors. But now she has set velocity and all of that physics stuff for us to move her around. So let's just do that. So this dot fawn dot set velocity. So we are going to want to move some amount of speed. Let's just say speed is 100. And then if you're going left, this is minus x, so it's going to be minus speed and no y. Moving left, we're not going to move up and down at all. Else this dot cursors dot right dot is down. This dot set velocity. This is positive speed since we're going right and not going to do any up movement. Let's just let's see. Else, if we're not pressing any buttons, right, we're just going to set no velocity. This dot fawn dot set velocity 0, 0. Okay. Look, she moves, but we're not changing animation. That's why there's no animation there. So this is the velocity. We also want to do anims.play, and if she's going left, it is going to be dot, what did I actually name it? Run side, right. Run dash side. And this will also be run dash side. Now we do know, we just tested, that, right, okay, so there's two things wrong here. She needs to flip, but also you can do ignore if playing. So you noticed it just basically stuck on the first frame because we're holding down the button. That's her right, that's her left, right, but she needs to flip on the left. So this dot font set scale, or maybe there's scale x -1, and then the other equals, the other is not minus, just normal 1. Here we go. Right, look at that. And then once she's doing nothing, we're just going to pick idle. So idle, idle down. Just say we're going to make this a little bit better. Look at that. See, just moving. Now we're going to do the same thing for up and down. Dot up, dot is down. No, this is TypeScript. This is the optional chaining operator, which is different than the null assertion operator, or the non-null assertion operator. Don't worry about it. This is just saying that if this is null, this will just stop. So instead of doing this dot cursors dot up not equal to null and this dot cursors dot up dot is down, it just saves us typing more stuff. You won't have this issue in modern JavaScript. Well, you'll still get a error if it happens to be null, but you don't have to do this if you're doing modern JavaScript. Okay, up. This dot atoms dot play. Let's see, run up. That same thing, true. Set velocity. This time nothing on the horizontal x direction, and then if you're going up, it's minus speed. And we don't care about scale in that case. And lastly, this dot cursors dot down dot is down. Let's just copy this because it's similar. And run down, and then positive speed. Up, right, down. Look at that. She looks alive. And of course, she's not running into walls. Okay, so in Phaser, we do need to add a collider. So this physics.add.collider before anything collides with each other. So we want it to collide with font and the walls layer. All right, let's see. And there we go. She walks into that. Not quite into that, so I'm going to show you why. First, let's turn on debug to see what's going on here. Debug true. All right, so this is her box, which is probably too big realistically. We can fix that. But look, she's going that, she's going that, going that. Everything looks right. Boom, and we look at that, and she flips totally out of her box when we go left. That's when we do scale x -1. There's a few ways to fix this. We're going to do the simpler version right now. And what we're going to do is dot set offset. Is there offset? Offset. Okay, fine. Set offset. I think there was dot offset. Okay. Dot x. So let's see. Let's say 16. Let's see what it does. It's going to be some multiple of 8, which is probably 32. I think her character is actually a 32 by 32 character, and the child's a 16 by 16, so she's a little bit big. But you saw here when we go left, she's good now, and then we need to set that back to 0 when we go right, because going right, 0 is fine with no scale x. There we go. So there we go. Now her box is fixed, and this collision works as you would expect given the size of her bounding box. So we can also adjust the size of her bounding box. It does seem a bit big. We can do this right here. So this dot font dot, I think set size here. Well, let's do it on the body. Dot set size. And so the width is too big. We're going to take her actual width and let's just have it. That may be too much. And then we're going to take her height, maybe 80% height. Let's see how this looks. It looks pretty good. Now, of course, our offsets are going to be broken, right? Okay, because we halved it, probably this should be 16 or 8. Let's see. Yeah, it's not 16. 16, maybe that was too much. Let's try 8. No. Maths. There's some semi-complicated maths, or not complicated, but let's think here. Refresh. So that looks like 24. Let's see which way it's going. Is it going more that way? Okay, 24. And then it shouldn't be 0. What does 8 do? Okay, all right, so there we go. Now our offsets are set. I'm sure this mathematically works out somehow. It's more convenient in this case, given that we're using tiles and these characters are designed for a 16 by 16 world, or a multiple of 8 or a multiple of 16 in this case. You can do this. There's probably a better mathematical way to calculate this, but I'm not sure what it is. It may take some time to set and actually adjust for it. Okay. But nonetheless, there's that. Now her box is right, so that looks better. That looks better. And that looks better. Now, real fast, you can see the camera's not moving with her, right? So she's going to go off screen there. We are going to have the camera follow her. So this dot cameras dot main camera dot start follow, and just now follow our character. We're going to turn true here to round pixels, just to give us, so that we don't end up on like fractions of a pixel. We may get some rendering problems like that. You usually see it, but we'll fix that later. So you see here, she's walking around, it's following her. Look at that, it's pretty good. Now let's see. Okay. I thought that rounding the camera would indeed fix it, but let's just see. Is there something else I can do? Let's go up here. Where am I making my tile set? I don't think this will do anything, but if I specify exactly my, does that help me at all? No, it shouldn't. Okay, we'll look into that, but there's still something we can do right now. As you can see, she always faces forward after she goes idle, which is of course not correct. And that is why we named all of these in the same format, right? Where we have the unique key, basically the character key first, then the dash, and then the actual state, idle, run, idle or run, and then the direction. So, which means when we come down here, instead of manually saying it's always going to be idle down, what we can do dot anims dot current anim dot key. And so that's going to give us this, right? Whatever the current key is for her playing animation. Then we're going to split this. There's different ways you can do this. We're going to do this real easy with the array split, or with string split into an array. Split by dash. We call this parts. So now we're going to have an array where 0 is fun A, 1 is run, or whatever the state is, and then 2, index 2, is the direction. So what we know is that 1 is the state, and when we come down here, we want to be an idle state. And then, so what we're going to do is play parts.join, and we're going to join again by dash, and now we should, here we go. Look, she's going to automatically, more or less, maintain or go to the right idle animation when you stop moving. So that looks pretty good. Okay, so that was moving the character. Before we go, and we will fix this rendering problem. Before we do that, let's actually do a mild refactor here. So this debug graphics is nice to use, and we're going to create a utils function. Now it is nice to use, but we don't really want to use it all the time. And what we're going to do is we'll call this debug.ts. We'll call this debug draw. And what it's going to take, we're basically taking this function out of our game class, or not function. This just basically the this logic out of our game class, put into its own function. Now we're going to want a layer, and that is, so we're importing this only for TypeScript type help. Dot tile maps dot tile, not tile layer. Oh, yes. So let's just say static tile map layer in this case. And then we need to give it a graphics, or we can give it a scene. What should we do? Let's give it a scene. Phaser.scene. So scene add, right? Because we're going to pass in the scene, and then we're going to pass in a layer. So now it's more reusable. The colors are the same. We can just leave that as is. So export debug draw. Okay. Go back to game. Can now delete this. Before we do that, let's import, and then go out to utils, our debug file, and then we're going to take debug draw, and then we can delete this, right? And instead do debug draw walls layer this. Now nothing will have changed. We'll still see this yellow highlight. Now if we do this, comment that it goes away. So now we can easily do a debug draw for any sort of layer we have, and turn it on and off, and do it multiple times or whatever, and not have it littering our game class. Okay, so that's for that. And that is it for this video. So we've got more coming. Next up, we're probably going to make an enemy, and then we're going to fix this little rendering problem you see. So come back for the next video. We're going to make an enemy. It's going to move around randomly so that it gives our game something to do.